At a high level, what does your company do?
Osni's a defense tech startup. We're here in Denver. We do research, but we're trying to build battlefield sensors. So we're trying to see that same market and say, okay, well, what does the Internet of Things look like in the battlefield? Very defense tech side of the business. So we're building a product for the Army called Nemesis. The idea is a proliferated mesh network of sensors, and then it has a microphone and a camera and a little like software defined radio.
Why would the commercial market care about counter UAS?
It's very easy to cause a tremendous amount of damage with $1,000 drone right now. Basically every business will start to see a need for managing their own either airspace or their own like drone platform.
What AI technologies are changing the military landscape right now?
Definitely data processing. The whole problem with the military right now is that we're like generating way too much data. Lots of sensors, lots of data collection, lots of legacy hardware.
Welcome back to the podcast. Today we have Dominic Parini. He is the co-founder of Ozni AI. Welcome to the podcast.
Thanks. Pleasure to be here.
Awesome. So at a high level, what does your company do?
So Osni's a defense tech startup. We're here in Denver. Basically, we do research, but we're trying to build battlefield sensors. So the main idea of the company is that proliferation of edge AI models and then edge AI hardware has kind of opened up a huge gap in the market where there's kind of like a dichotomy. You can either do really, really impressive software and hardware work at a very high price point when it comes to anything like defense contracting, or you can do like really, really expensive, really like low capability hardware and do it like at the edge. But now there's room in the middle to do really high quality software and really like not low quality, but low cost hardware to start proliferating more capable sensors and things like that into the battlefield, but also into commercial industries for infrastructure, security, et cetera. And so that's the opportunity that we kind of saw with the company. And so we left our jobs, started Osni, and then we've been on contracts to basically build prototypes of the sensors that we see like a gap to build ourselves.
Okay, so
Mhm.
so it sounds like you have this middle ground where you have cheaper sensors and really high-end software, and you're combining those together.
Yeah, pretty much. Like I think that that's the best way to put it. It's the hardware is like really impressive. It's mostly coming from like companies like Nvidia. They want to mass produce these GPU kind of like enabled systems, like little Jetsons and Orans and Nanos, like all that product line is its own thing for robotics, manufacturing. They want like a GPU in every system so that they can all be intelligent with like language model architectures. That's Nvidia's thesis, and it's working pretty well. They're worth like what, four something trillion dollars. But yeah, so we're trying to see that same market and say, okay, well, what does the Internet of Things look like in the battlefield? So very defense tech side of the business, but that's pretty much the niche.
So each of these sensors has a little GPU in it.
Pretty much. Not always, but the the underlying technology is that GPUs brought us the hardware required to run like small generative AI models in certain places. And that's what people think is going to get us to the next stage of having intelligent things kind of all around you. And
Yeah.
so, yeah, pretty much that.
So with the GPUs, then you must be using some type of deep learning on these sensors.
Um, Basically it depends. Like we're building a couple of different products. So we're building a product for the Army called Nemesis, and you can go find it on like our actual contract online. But basically the idea is a proliferated mesh network of sensors. So each sensor has its own little compute stack on it, which is this like NVIDIA hardware. And then it has a microphone and a camera and a little like software defined radio. And you take all of that data, and what you used to have to do is stream it over a network back to your servers, right? And then you do all your data processing, and then you decide what to do about it. And that all happens somewhere in the cloud, right? Companies like Palantir do this. That's just kind of the traditional hierarchy of data processing.
Mhm.
What we're trying to do is remove basically all of that and say, what if you can do the entire sense making process on the sensor itself? So that instead of having the sensor there and the decision maker somewhere else, you can have the sensor in the battlefield and you can pick it up and ask it, what did you see? Like, what's the current state of this area? What is your local understanding of this environment? And so for the army, like the use case is we want to take the foxhole scout out of the battlefield, out of that harm's way tactical edge position, and essentially replace that with a $2,000 computer. It's a lot cheaper to replace that than it is to try and evac somebody, or just like the risk of putting a human in that position is what we're trying to basically outmode.
Okay.
Mhm.
So a big benefit of doing it on the edge like this is that you don't have to stream it. So,
Mhm.
number one, it sounds like you would have more security,
Mhm.
and number two, you can do this in places where you might not have any internet connection.
Yeah, yeah, that's definitely part of the idea. We're talking to some companies that work on non-terrestrial networks, so think like Starlink. And having the ability to put your sensor somewhere that doesn't have internet connection, but then still get like a phone home that, hey, like my time has come, like I found the thing I'm looking for. That kind of one-way signal is really interesting. We haven't solved that problem yet. That's this we're still like well into the R&D prototyping phase, but that's a big motivation of why we're trying to build that product. And then to kind of go a little like one step further, we want to commercialize that. Like we don't want to just make one thing for one customer, like the only for the army. So we're kind of breaking out that whole product idea into multiple capabilities that we can either sell to commercial users or license as a software to other companies and things like that. So we have a few different strategies for the underlying tech. Um, but one of them, for instance, is like perimeter security. Like if you've ever looked at a security guard, they are almost always sitting in front of a screen with like 60 cameras on their monitor, right? And
Mhm.
that's like kind of you know it's intellectually exhausting. It's hard to 100% of the time identify all those anomalies and things like that. And so if we can take the sensor stack, the software that goes onto our little sensor, and then license that to the company that has 400 cameras at their building, and then just each one of those basically is its own small software sensor that reports an anomaly when it sees something different, or hears something that it should be seeing one thing but it's actually seeing another. Like that kind of fusion of different forms of collection allows you to detect anomalies that you wouldn't be able to see previously. So a lot of that is what we're working on the software side, and then yeah, trying to turn that into other products for other industries as well.
Okay.
Yeah.
And with that capability that you were mentioning, that's still in R&D,
Mhm.
where you might have a phone home
Yeah.
capability. Wouldn't you also want to have the ability to send it a message as well? So, like maybe it's
Uh-huh.
usually works all by itself, but you can send messages in and occasionally get messages out.
Yes. Mhm.
So for these GPUs, how much VRAM are you really working with?
Uh, it depends. At most, if you have like an Orin AGX kind of series compute board, that would be like 32 gigabytes of VRAM.
Okay.
But usually a lot lower. So you're talking like what I would really like is a mixture of experts, small large language model that has a reasoning capability in like the 7 billion parameter model and less.
Okay.
That's what I would really like. That gets your power consumption really low, and so your battery now lasts you a lot longer, and so you can put the sensor somewhere really austere for a really long time. So yeah,
Interesting. And I'm sure you're also quantizing that down. So 7B, 4-bit quantization.
yeah, especially with like the DGX Spark is a really interesting product, because it's built on I think the architecture name is the Blackwell architecture, so they're like even further quantizing. So that product has like 128 gigabytes of like I think unified memory. It might be still considered VRAM, but you can run a 256 billion parameter model on it because it's like 4-bit floating point instead of 8-bit. I'm pretty sure those are all the right numbers. It might be
Eh,
like half or something like that, but
Yeah.
but that's the newest chip architecture from NVIDIA, and then now they're making it for the first time into like their small form factor. So I think you're going to see that trend continue. I think it'll be interesting to see what happens when we start looking at 2-bit and even 1-bit quantization.
Yeah.
Um, it's kind of I think it's an open question as to whether or not that'll be like realistically effective, but who knows? Like that's where the theorists are still working on it. I feel like.
Yeah. I remember back when I had my fully remote podcast, I
Uh-huh.
even had a researcher who was looking into the 2-bit and the 1-bit quantization, and he was talking about how there are some parts of the transformer model that you can quantize down to that, but
Uh-huh.
then there are some parts that you have to have in a slightly higher precision.
Yeah.
Um, but yeah, so yeah, it would be interesting to see. It would also be interesting. So I know some GPUs actually have 4-bit tensor cores, which allow you, if you're in a 4-bit quantization, such as like the A100, it processes it natively in 4-bit, which allows it to be much more efficient. Versus like if you had a GPU that doesn't have that type of tensor core, you're in 4-bit, but you're running the calculations in 16 or 32-bit still.
Yeah. So it just defeats the purpose essentially.
Yeah, like it's still it's more computational power. At least you can still store it in the GPU
Right.
in 4-bit, so you get the memory savings,
Yeah.
but then the speed of the calculation, you don't really have that type of savings.
Yeah. Yeah.
So
That makes sense.
yeah, it would be interesting to see, like an edge device like this with a 4-bit tensor core that could probably enable even faster computation or lower memory usage.
Definitely.
So when it comes to trying to run these types of models on an edge device like this, are you using a computer vision native type of model like a YOLO family, or are you looking at vision transformers as well?
Yeah, that's a good question. So it depends on the swap, right? Like if you can get away with it using a segment anything model with built-in object tracking and um, like maintaining object custody throughout multiple frames is really nice. It solves basically all of your problems
Mhm.
in the classical computer vision sense. But if you don't have the compute to run that, and you have to start scaling back down. So we kind of exist all along that spectrum where we've got like a server grade software deployment of the autonomy stack, and that just uses as much resources as it can get. And sure, it's going to use all the big models. It's going to use open vocabulary. You're going to be prompting it. It's going to have a vision language transformer kind of like in the back end at some point. Um, but kind of refocusing down to that little sensor, what you need to do is a certain amount of pre-processing and filtering your input data stream with something like YOLO, something that's super fast, basically consumes no power, and then can give you metadata that makes it more reasonable to have those more expensive processes come and look at your individual frames and things like that to do some inference on. One
Yeah.
thing that I've found that's really challenging about this problem is that when you think of like the whole category of technology that's serving video search and summarization, NVIDIA is really big on this. If you go to GTC, there's like trainings on this every day. And it's basically give every frame to a vision language model and ask it to describe what's happening in that image statically, and then append all those descriptions together and ask it to summarize it. Like that's the very crude way of thinking about it. And that's not good enough. Like
Mm.
we need some sort of breakthrough in like video native inference, right? Because like if you think about human intelligence, we're constantly processing video, we're not processing still images. And so that's what makes us really capable and intelligent in real time. And robotics, I think, will kind of like shudder up to that point if we can't get past this like still frame image processing. But
Yeah.
that's just my thoughts on the issue. I'm still like kind of surprised every time I see a new computer vision model that kind of deviates from the path, but still is doing static image processing and just batching it. Um, how
Yeah.
capable they're getting. So I might be proven wrong, but I don't know if I will.
Yeah, interesting. And also, do you consider like how many frames per second that you're doing? So if you have these compute restricted environments, you might do a few frames per second, but if you yeah, if you have more compute, you can do more.
Yeah, you're right on the money. It's basically if you have like a Raspberry Pi, you might do 1 frame a second. So you have to make sure it's the right frame with all these pre-processing steps. But if you have an Orin AGX, you might be able to do 30 frames a second, and then that might be good enough for your entire feed. Um, but yeah, it's challenging. And then it's challenging when you're trying to simultaneously do acoustic detection and classification, and then also manage a software defined radio and do signals classification, and try to do like demodulation of all the signals around you, and see what's going on in the RF spectrum. That's mostly where my background is from. Lots of signal processing and RF geolocation. So receiving a signal and then figuring out where it came from. Um, and that's a big part of Nemesis. Like having distributed terrestrial sensors is nice because now you have lots of these in theater collectors to get your signals intelligence from. Signals intelligence is almost exclusively like a technological thread for military. There's almost no civilian use case for signals intelligence or any kind of RF geolocation except for counter UAS. Basically, um, that has been the one reasonable use case that I've found for bringing a signals intelligence product to the commercial market.
In that commercial use case, it sounds like if you need to be able to attribute it to someone, then that means that you need to be able to detect where the signal's coming from. And then beyond that, would you need multiple of them to sort of triangulate where it's coming from?
Basically, yes. So now we're talking about RF geolocation, and so when you're trying to geolocate the source of like an RF signal, which might be the command and control signal from the operator, you need to know where it came from. And there's a couple different ways that you can do that. You can have a directional antenna. So like if I detected it at all, it came from this direction, right? So that's one way to do it. Or you can have multiple antennas, and then if it detects it at multiple places, you can basically triangulate it. So that's why the whole concept with these distributed sensors is that you have many of them and they collaborate in some meaningful way to produce that end result.
Okay.
Yeah.
So if you did have these end sensors that were collaborating, but now they have to send the signals and you get the fingerprint,
Yeah.
but that would be fine in a commercial standpoint.
Totally fine.
Yeah.
Yes, and it's much easier because now I don't need a battery. I can plug into a wall somewhere, and I can transmit, or I can just, you know, connect to a server. Like I don't have this like hierarchy of signature management that I'm trying to avoid data processing centrally. Like now it's 100 times easier. Um, you just need to solve the technical challenge of detect and geolocate. So yeah, it's nice because the civilian market has that more like kind of bounded and defined problem space. But ultimately, we're building this product for the military user, and then we're kind of just stripping away certain pieces that you don't need in the civilian market. But yes, to your point, it's exactly that.
So how much do these commercial companies actually like spend for a solution like this?
That's a good question. Um, It depends, and I don't really know.
Yeah.
So basically, like, we're a startup. I'm an engineer. I didn't spend decades in like security or counter UAS.
Yeah.
What I can tell you though is that, when it comes to like perimeter security, there's companies that'll spend $300,000 on a gate. So like when it comes to like a sensor deployment, um, it can be tricky, doing sales in this kind of space because especially with like an RF detector, like what is the value of that? Um, it can be hard for people to understand like even what the coverage of their sensor is, and let alone like if they have some site that they're responsible for managing the security of, if they put like a camera on top, they might just be like, yeah, we got a camera, we're good. But like there's probably blind spots and like, who knows? It's this whole game of cat and mouse at that point. But it does take a significant effort to get to a point where someone understands the value of your sensor and your detection capability, and then is going to be able to go and get the authority to purchase it. But I think that just seeing is believing. And so we do our best to, get our sensor prototypes out, fielded, tested as much as many venues as possible. Um, we're just talking to a company today who is going to 50 events for the rest of the year. So like, almost on average like two a weekend, um, just doing counter UAS. And so, yeah, we're going to be very excited to go get on one of their events and put up our sensor, do some data collection, see how we do. Because we're doing R&D prototyping. But there's a lot of companies that are more mature than us. There's a lot of companies that sell very expensive equipment, and that's kind of like back to the first thing I said with the exquisite hardware. You know, there's a lot of people who can do some stuff, and it costs $500,000 or $1 million for their one sensor, and it might be have a great range. It might be very good. It might be well connected to the cloud infrastructure that the company uses, but it's very expensive. So what we're trying to do is, make things that are one for the military attritable, and since that's our primary focus, that's what we're doing. But attritable being that it can get killed and you don't care. Um, but if you make something that's attritable for the military, well, it's also now on the civilian side cost conscious. It's now a value product. And so we can deliver a product that's, two orders of magnitude less expensive than a competitor. And you might need six of them instead of one, but then you'll get a similar capability. And I think that that's our kind of go to market strategy in the next like year or so. We're not there yet. We're not selling produced sensors or anything like that yet, but that's certainly kind of the direction that we're tending.
Interesting.
Yeah.
And if you did, when you get to that point where you are selling it commercially, would it be something where you would need to provide some like consulting just to explain how to set it up, where to put the different sensors, or is it something they would be able to figure out themselves pretty easily?
Yeah, that's a good question too. We thought about that, and then we basically built like an internal tool where you can like load up an area using like Google like Maps and like Google Earth terrain, and then some OpenStreetMaps like data sets and stuff to see where the buildings are, and then like drag your sensor around and see what its coverage is. Um, and so like if you put it under a tree, it's like, well, great. Now it has no coverage because it's completely obscured by the environment. Um, and so this tool we called it Mesa, but basically we built it for ourselves just to answer that question of where do we put our sensors, how can we optimize their deployment, and can we do that before we get there? Um, and we've recently started piloting it as a software service to other companies, so they can load in their sensor and then maybe ours as well, and then they can like put them side by side, see what the ranges are. Like, do they detect the same drone equally or whatever? Um, Basically, it's like a site planning tool, and so that's been kind of like an orthogonal, um, you know, business strategy for us as a startup. Is like, you can't be afraid to pivot, and we're not going to pivot away from anything that we're doing, but focusing on a potential like software as a service product that we can use to partner with other companies now, and then a year from now when we're mass producing our sensor and like actually have the product in the field, now we already have all the companies that are doing this as our partners, so we can then go and say, hey, let's like put our sensors together. Look how much more green this made our detection coverage look, that kind of thing.
Yeah.
So yeah, kind of like a software planning tool that we're going to be able to use as a sales engine in the future, but currently is just kind of, something that we're offering to other companies if they want to work with us. Like that's another like niche that we found. And those are honestly like the two big focuses of us right now. We're not that big. We're only 7 people. So we have to really pick and choose what we focus on. But
Mhm.
but yeah, those two things have really, felt like a kind of moment.
For that Mesa software,
Mm.
how do you find the people who want to connect with it and who want to actually use it?
Oh yeah, that's a really good question. It's really hard actually. Because like you might find the right person who's like got the right job title at the right company, and you met them in the right counter UAS expo or something, some like conference, and then they might look at it and just be like, "Yeah, we don't need this." But there might be 40 people standing behind them at that same group at the same company who like desperately need that thing. And the trick with business to business sales, which is what this kind of example would be, is that like you are not selling to the person buying it. You are selling to someone who is hopefully informed enough to know their own requirements and hopefully has enough authority to like get the sale done, but almost never is that the same person. So you need to sell to somebody, give them enough materials to prepare them to go sell it to whoever has the purchasing authority at their company to then fulfill their requirement by purchasing your thing. We have not cracked this code by any means. We have like half a dozen pilots that we're putting out there, but like like any good software salesperson would be able to tell you, you need to be, constantly talking to 500 different companies, not five. So that's kind of where we're at. I'm like an engineer trying to solve like a very common like sales problem. Um,
Mhm.
and unfortunately, it's not like solving the traveling salesman problem. It's not just an algorithm. You have to go talk to people, meet them, make them like you, like, understand their problem, offer the solution, and then yeah, don't even get me started on figuring out how to price something like that. So yeah,
Yeah.
it's a really interesting challenge, but it's definitely not unique. Pretty much every like business to business software as a service company will end up having the same problem or has already had this same problem. Um, and so yeah, I'm very ignorant in this space at this point. Like we just got here and we're just like, hey, has anyone else dealt with this? And everyone's like, yes, thanks for opening your eyes. Um, but yeah, it's interesting. Yeah, we definitely haven't figured it out quite yet. So if anyone has advice or wants to buy Mesa, let me know.
Yeah.
Yeah.
Do you find yourself spending a lot of time on this in your day to day more recently where it sounds like you go to these conferences
Mhm.
and then at the conferences you try to meet people, build a connection and maybe provide them with enough information that they can give it to the one who actually has the authority to buy it?
Yeah, pretty much. Like I've went from being like a 100% engineer at my past job, and then like when we started the company, I'd probably say I was like a 80% engineer and like 20% like product designer slash proposal writer. And now it's like unfortunately I'm probably like 50% or maybe even 40% engineer, and now it's like 40% product designer slash proposal writer. And then now it's like 10% like callback salesperson. Like, please, like tell me what you need to like, get this going. Um, and so like, yeah, you have to wear so many hats. And like, yeah, right now they're kind of changing, it seems, for me in particular. But for our team, luckily, like we have a lot of people who are really dedicated individual contributors. Like they just want to, they're gonna write the software and like make it work and make that product real. Um, which you absolutely need. But if there's no deal and then there's no money, then there's no company and then there's no product to make real for the software engineer, right? So
Mm.
some like yeah, we're basically figuring out how to do that. We've even thought about potentially like finding a way to bring in someone who knows sales and like help us, but we're also pretty stubborn and we're like fully bootstrapped. Like we haven't raised any money. We're just doing this all from our own luck, I guess. um, but yeah, so we haven't quite crossed that bridge.
Yeah. I'm sure it can be challenging as well if you hire a salesperson. That salesperson has to be able to answer questions kind of at a level that you answer because they might have to field these questions
Yeah.
and so yeah, if you just hired a salesperson that seemed like they were really good at sales, can they do it for this SaaS product which is highly technical?
Yeah. I mean, it definitely would take a particular kind of person. Um, but I think, almost any job does. And when I think about all the people that we've hired, like we've only really hired within our network. We haven't posted any job postings yet. Like even when we, needed to staff up, like we knew people and we knew that they were good at what we were going to ask them to do. And so we also, as a startup, like have not had to broach the point of how do you hire someone that you didn't already used to work with. That's going to be really challenging as well. I don't know if you've like had people on the podcast that have a similar problem or have solved that problem, or even I'm sure there's a lot of people who like I've even met some people who have co-founded businesses with basically strangers. I that wouldn't be for me. That would terrify me.
Yeah.
But yeah, like this is also something that like as a startup, as a small business, like we're going to need to solve. That's pretty obvious. But yeah, we luckily haven't had to solve it quite yet.
Yeah. Up to this point then, um, maybe getting your first customers, that's been mostly as well through people that you know, your
Yeah.
connections?
Yeah, like having a big network is huge.
Mhm.
That's super helpful because there's this like concept that people in San Francisco always talk about, like all in that like startup venture space called champions. Um, and like I don't know if I'm just like saying things that are very bluntly obvious or something, but basically like it's important for you as a startup to have champions because you basically need that person in that organization to champion for you and make that deal actually happen. And I thought that was like a kind of stupid nomenclature to use because it was like, okay, well, obviously, yeah, like it's great if people advocate for you. But no, that is absolutely like deadpan necessary to getting anything done. You need someone, especially on like customer zero, like the person that you're building for, even before you're going to sell to them, like whoever you're thinking of in mind. You definitely want to have a champion there because you could then go build a product as a business to business company that has no end user. And then if you don't have that person on the inside who can kind of tell you like, yeah, what you're building kind of won't work for us. Well, then it's if you're building it for them, it's certainly not going to work for other people. Um, so being able to like maintain your alignment as a company, and then also like once you do get something that has a compelling value proposition, being able to go to market with that and have someone on the inside that can like advocate for you to that customer is like I think that that's really important. Um,
Mhm.
but but yeah, your network can be anyone though. Like it's just, if you get a warm intro from somebody who you met at a conference for 5 minutes, or if you just saw the same person twice in the same month, like going to all these like in-person networking events or conferences, like I found that to be incredibly valuable to a certain degree. Um, where like I might not at this point spend a bunch of money going to conferences and expoing and putting up tables and stuff. Um, last year I think I went to like probably like 16 conferences. Some of them we were presenters at, some of them I just went to and attended the expo floor. And then some of them I didn't even go to the expo. I just went to the after parties. And like even that it can be incredibly valuable because then you see the same person from the last thing. And it's like, okay, now I get to talk to you again. And maybe this will actually cascade into something for the business being strategically important. But yeah, the network is 100% everything because you can't do anything in a vacuum.
Interesting. Yeah. Yeah. There was a previous person I had on the podcast a few days ago that talked about how a big way that he would get his customers is that he would give these keynote speeches, and
Yeah.
he would give like two per week sometimes, and
Whoa.
yeah, he got a lot of success out of that.
I'll have to listen to that episode. I must have to learn from him.
Well,
Wow.
yeah, well, that part of the conversation was kind of the after part. It
Oh,
wasn't actually recorded on that
dang.
part. Well, I
But I believe it.
yeah, we may have talked a little bit about it,
Yeah.
but yeah. Um yeah, it was pretty interesting. So, on the part where you're fully bootstrapped, what is your strategy around not wanting to bring in outside investors?
Yeah. So, I mean, me personally, like, when I don't take my cars to dealerships, I don't like take my laptop to the Apple store. Like, I like to do everything myself, which is probably a huge character flaw to some degree, but I do like it. And so like my co-founder Justin and I like we found pretty early on a good opportunity to raise non-dilutive funding. Um, and I can go into that a little bit. So basically, the government, mostly from the Defense Department, but also from other parts of the government, like the National Science Foundation and just like NASA, like other organizations in the government, will post solicitations to the SBIR portal, so Small Business Innovative Research, and they're just types of contracts that only small businesses can apply to. And small businesses are defined as under 500 people and under X amount of dollars per year in revenue. Um, so these contracts are usually go build something that doesn't exist yet. It's thought of as America's seed fund, and they can award you up to 2 years and $2 million worth of funding to do something, right? Whatever it is that you propose to their solicitation. And then if they accept you, you could win up to that much money. Um, and then you keep the data rights in most cases. So if they solicit, I want you to build me some sensor, then we propose, yeah, we'll build you this kind of sensor. It'll, we want $2 million for 2 years. And they say, yes, cool. Then you can build that. And then once you've built it, you own it. It's not like you built it for them like a normal contract would be, because like usually you get like the IP or the actual thing or the money, and not all three. But in the case of SBIR programs, you do get all three. There are lots of rules and limitations and things like that, but and they're also very competitive. I think the average SBIR win rate is like 10% or maybe even lower. But that program specifically from the Small Business Administration has allowed us to basically raise over $4 million across a couple of contracts to build these prototype sensors, hire the people, build the products. And then now our mission is, before that timeline runs out and before those contracts end, get into a position as a business where we can then get more revenue, sell our sensors, whatever it might be, find the end users for these things. So we've been really really successful with that. Um, just with two contract awards that we were awarded, but there are also, on the kind of flip side, that because that all sounds great, there are lots of 499 person companies that just farm SBIRs.
Oh, dang.
Yeah. I think like I'm not going to cite a statistic, but a vast majority of SBIR awards go to basically like 24 companies in the country. Um, the program itself, the whole SBIR government authority, was actually in jeopardy for the last 8 months because it didn't get reauthorized when the government first shut down and the new budget was passed. Everything passed, not everything, but like all the stuff that passed left the SBIR authority behind. So for the past 8 months, we've had no new solicitations. So there's no new opportunities to have an idea and then propose it to that customer and then win another contract. Because like one senator in Massachusetts gets a bunch of donations from, a huge 499 person company. And that's like a really popular employer in their district. And so he was like, I'm not going to approve any SBIR contract that limits the number of awards that a company could get. Meanwhile, everyone's like, dude, if you've gotten $100 million from the SBIR program, you probably are good. Like go actually develop some technology. You don't need seed funding anymore, right? It's like, that's, if you're a 30-year-old startup who's raised $100 million and you haven't built a business out of that, like you failed. Um, unless you're a SBIR farm. Then you just keep getting money because you keep writing proposals, then you publish your white paper, and then you do it all over again 2 years later. But with 400 people doing that simultaneously. So the odds are stacked against you as a small business from that perspective. But like the government's actively trying to fix it. And then there's parts of the government that are trying to prevent those fixes from going in place because of special interests. So I never wanted to learn about the logistics of the SBIR authority. And like, as an engineer, like I never want to care about that. But when all of a sudden, like our business's main line of like, okay, if we wanted to grow another couple of people and we have another good idea, like how can we kind of, three-prong this and get another proposal out? It's like, well, now we can't because the authority was gone. It just got reauthorized for 5 years, I think. And so that's like a silver lining, but it didn't really address any of the major problems substantially because of that one dissenting, literally like one person. Um, so yeah, it makes the small business side of things really possible if you're particularly interested in doing something that's dual use or defense centric, but also has a commercial market. That's a big emphasis of the SBIR program. So yeah, that's basically what our strategy has been. And then just one step further from that, venture capital is really like, you get your seed funding to start the company, get the idea, or pre-seed gets the idea, seed gets the company kind of going, and then you raise money from VC firms to solve problems that you have money related, right? Like if I had to go stand up a factory, hire 200 people, and then like start making things in large orders, like that's a problem that only money can solve. So I need to go raise VC. So far, we're just working on technical challenges, like we're working on algorithm development, data collection. Like, sure, if we had more money, we could hire more people to do this better, and that's kind of what seed funding would do for us, which we've considered, but we're not actively trying to raise money right now. I think that once we have kind of gotten to the point where okay, scale is our current bottleneck, that's where we'd be interested in like raising money and then going after VC funds to solve that problem. But realistically, like we don't believe that we're currently at that head yet, and we haven't been for the past like year or so. So yeah, that's the long-winded answer, but that's how our company has gotten to where it is.
So these main products, I
Mhm.
think you've talked about two products that you're
Yeah.
creating. Those are coming from those two contracts that you got for SBIR.
Yeah, basically. Not exactly. Mesa is like our own thing that we've just developed ourselves. It's not a part of any specific contract. But Nemesis is one of those. Yeah.
Interesting. Okay, cool. What AI technologies are changing the military landscape right now?
Definitely um definitely data processing. Like the whole problem with the military right now is that we're like generating way too much data. Um Lots of sensors, lots of data collection, lots of legacy hardware like in the back end, cuz the military is like way ahead of its time in a lot of ways. We made the F-22 in like the 80s or something. Like we originally designed it like way back then, and it's like then for 45 years been the most dominant aircraft in the skies. Um, but then like no matter how far ahead of their time Skunkworks was, the data processing hardware, if it was specific to that program, like because everything's siloed into like directorates and programs and then like groups and products and things like that. Um, but like you don't have this evolution of like cloud computing where everything for consumers ubiquitously just got cheaper. Like iCloud. Now what? You get 100 gigabytes or something for like 99 cents a month. That's not an advertisement. That's just my memory. But I'm trying to make a point of like 100 gigabytes of storage 10 years ago was like way more than that. And so we've got this like almost ubiquitous like data is free, like compute is free, like almost relatively speaking. Because if you try to buy your own data center to actually get how much compute you have access to, you'd be crying at the price tag. And that's what the government does. They cry at the price tag and then they like pay it or something. Like you end up with lots of legacy hardware. So what I think that like AI has done as a field, so I'm talking about now machine learning, not generative AI. Like machine learning has done a lot. You get lots of data, like government has lots of data. So you get lots of data driven products that are increasing the capability of some system. You might get um, like autopilot in planes when like the pilot is disabled. Like I think in Broomfield last year, you actually had like a King Air land itself because a pilot went unconscious. So, think about that being translated into a military context. That's an amazing capability. That's a good example of a capability that the Army or the Air Force might want for their systems from AI. When it comes to generative AI, though, I think that the impact has been had like a little bit less yet because GenAI.mil I think is the current big push for having the chat bot at the Pentagon. Like everyone in the Pentagon now gets to use all the chat bots. And
Mm.
like it just wasn't like that before. So I think that we'll see what the impact of Gen AI will be on the military, but I don't think that it's quite been had yet. Um, but certainly machine learning has been like a huge disruptive force throughout a lot of the like specifically ISR technology, like anything reconnaissance, like finding stuff. That's just what AI does. Like it's really good at it. So yeah, I think that like there's kind of two sides to the coin, and they're definitely just like a late adopter to a lot of this stuff. But certain groups are worse are better than others in terms of actually going and getting the newest tech and then bring it into their tactics or their procedures or their organization. Um, and yeah, it's like a whole mixed bag because the government is not one thing. It's like 2 billion things pretending to be one thing, right? Like it's a very complicated system, lots of different hierarchies and authorities, and it constantly changes who's in charge of it. So like that's disruptive. Like it disrupted our own like contract timelines for like 9 months last year, just due to like the series of events that cascaded from um, like all of the like change of administration, Doge, shutdowns, politics, SBIR reauthorization, like all these features of our government, like that's essentially what they were, like cause things to not work efficiently. And so it's then hard to adopt new stuff.
Interesting.
Yeah.
Yeah. And so for your background, I know that you were previously working at Northrop Grumman. What inspired you to go out and start your company with this co-founder?
Yeah, so Justin was like my chief engineer in the lab that I worked in. And we worked together for like a little over 3 years. And he had a lot more experience than I did. And I also had like an appetite to start a company. And so it really was like kind of circling back to the very beginning, seeing the opportunity of like edge AI hardware, AI models, and like the fact that they would update, like you'd get a new capability or a new model would come out every like 3 weeks, and we're sitting back in Northrop with an annual IRAD cycle. So we had to, in October, define our objectives, propose the IRAD, get the funding, make the plan, and then work that until next October and then come up with the results. Like that cycle time is too long. And I'm not bashing Northrop. It's a great company that makes, it's the only company in the world that could make the B-21 Raider or the B-2 stealth bomber. Like that's just indisputable. But it does not have the gearing to do these small, nimble tasks of adopt the new AI model, build a system for it, and then make it useful um, at the pace that we were trying to do that in for now what we're doing at Osni. So, we take a lot of inspiration from what we did before, but it mostly just comes from the fact that we are a group of like AI engineers. We've always been working with machine learning algorithms, and now we're doing a lot with reasoning and language models. But finding use cases for the newest AI algorithms is only really feasible if you're able to adapt to the newest AI algorithms and watching them come out and using them, um, rather than trying to do something very deliberate and very, kind of like, um, I don't know, like you when you have to do something that requires a long lead time. It's just not as feasible.
Another thing out of curiosity, so going back to how you have these sensors with these GPUs and you're in this resource constrained environment, do you also look into fine tuning those models so that you can get a smaller model with similar performance?
Yeah, definitely like in both ways that you could think about this. So like the machine learning models, we actually do a lot of work on taking a generally good model, like think like a YOLO model or something like or even like an open vocab model, and with a little bit of data on like a target that you don't know much about, like target label of whatever it might be. It might be like if you've trained on all the Porsche models and then you just want like the Carrera RS from the 70s. It's like, okay, that's a rare target. I need to get a model that's going to be really good at detecting that, even though I only have two images. So bootstrapping from the original model, training like very heavily fine tuning on those couple of examples is possible, and we do that. Um, and
Mm.
I think that that's like an interesting strategy because the market and the foundational models that are coming out, foundational just being anything that is pre-trained in my current use of that word, but like all these pre-trained models are coming out tons of data. That's great. Bootstrap off of that. They have good performance. Um, on the other side of things, the language models, fine tuning small language models is really interesting. I think it's really capable, like, especially if that language model is going to have a task. So if you need it to do like structured output of a few fields in a like a JSON query or maybe something more LLM token friendly, but
Mm.
um, being able to fine tune a small model with like a teacher student architecture where you have like a huge model that you might be hosting or even hitting an API for, and then training that little model to perform that task well, even though it's like doesn't have generalizable knowledge, can't do search, can't do tool calling, but maybe it can output the correct structured output really well on half a billion parameters. um, I've been super impressed with what we can do with that. And I even did some of that work in my grad program at Virginia Tech. I like when I was working, I also did classes for my master's degree at the same time. And so like one of my projects was specifically on that, just teacher student model performance distillation. And you can bootstrap really well for specific tasks, which you would expect to be able to do. Um, but yeah, it's just impressive. Like, I mean, language models from the start, it's always been, yeah, zero shot learning is like the capability that they're known for. But like the actual like post training fine tuning has been really impressive.
Yeah, yeah, it's crazy to see that you can get these fine-tuned models that are really small, and you can get similar performance at 1/100th the cost.
Uh-huh. Yeah, absolutely. It's still like, I'd say a question of, for most cases, would I ever fine tune a model just to like get my token usage down or something like that for a specific task? The answer is probably no for me as like a software developer. But when it comes to fitting it onto a smaller piece of hardware, and so that might be for other software developers, if you're trying to build something that can run in a browser or run on a mobile app, like now all of a sudden maybe fine tuning a small model would be correct.
Mhm.
Yeah.
Yeah, and another thing, so we were previously talking about we have these drones, and one of the challenges is that you either need to have a fiber connection, or you need to use RF, or you have to have it running entirely on the drone. With the part where you're running it entirely on the drone, aren't a lot of these YOLO models and these other computer vision models, they're small enough that you should be able to run it even with a relatively small hardware?
Yeah, like YOLO is like, the actual weights of that model are like a couple hundred kilobytes, maybe, I think, like that. Like it's
Yeah.
super small and has been very well quantized due to just like the popularity of it.
Yep.
There are even now like models that match the performance of like the biggest YOLO models at way smaller sizes, um, coming from a bunch of different companies. I don't remember their exact names, but um, one of them in particular we found really interesting that we saw in a research paper where they basically had like reinforcement learning trained a model on the output of YOLO that was even smaller than YOLO, and then just teacher student bootstrapping got something that did that task really well. Um, so yeah, like the smaller models being distilled is interesting. And like DeepSeek had that, right? Like that was like the whole headline that crashed the AI market. I think it was last year when DeepSeek like made a splash, and it was like, oh yeah, well they only took $6 million to train this model. Well, it's because it wasn't training, it was like distilling. And now they're making their own models in a really cool way. But I do think that like obviously, because everything is like this, you get this like diminishing return on performance. So there will be people who push that boundary of performance really like all the way that they can with the super labs. And then like luckily the distillation process is super cheap. So like the bare minimum performance is going to just stay super close to that as it kind of continues on. Um, and like that's great for consumers, that's great for end users, that's great for engineers. So yeah, I think it's really good to see the success that people have had with model distillation.
Yeah. Then what are your thoughts as well where you have these systems where you have the cameras, you're keeping track of maybe different objects, but then the object might leave the camera's view and then it might come back. And then what are your thoughts on how you're keeping track of, is that the same object as before or is that a new object?
Yeah, that is a good question. Technically, there's like two ways to solve it. Uh, I'm sure there's more, but one way to solve it is with like business logic, like from a programming perspective, just like registering certain features, expert defined or even features exposed from the neural network that did some classification on that object, and then like
Mhm.
storing that in some array of like recently found like objects, and then comparing that to newly detected objects and seeing, okay, is that at all similar to any of my recently found and departed objects from my frame? And then like if it is, then link it. And like that is a very like 2020 answer to the problem. The other side of the question, which is kind of like a cop out answer, is I bet 2 years from now the AI will just do it. Um, and like there is this higher level technical idea where I think it was Sam Altman who said this, but I can't remember exactly. And it was like, as an AI company, if you're building anything in AI, you are on one of two sides of this statement. Either you're building something that the AI currently can't do, and it will be able to do in the future, which will outmode everything that you're doing. Or you're building something that the AI maybe currently can't do, but as the AI gets better, your thing will get better. And I'm very much trying to be in the second camp. I would like to be able to do all that business logic programming and get that feature now. And then if the AI can do it 2 years from now, awesome. I delete all that other crap. And then now I just have a better embodiment of the AI model that will be able to perform that task. But you certainly can't count on that, I think. You have to do a little bit of both. You have to do the business logic programming and actually get the capability to be at that cutting edge of, solving that problem. Um, but let's be real, the AI will probably be able to do that. Like I think I'm just comparing like 2022 AI models, even just like, yeah, computer vision to now. Like look at Segment Anything 2 from Meta. You can click on something and with one point as the like prompted point source for that mask, get a full track in frame and sometimes a little bit out of frame. It's not very consistent with that, but out of frame, like with that like coherent object being tracked in frame. And like to people who are working on YOLO like 10 years ago, that would blow their mind. So I think that like we do kind of take for granted a little bit how much AI has just solved that, like to problems of our past. Maybe as software developers, maybe not, but I do think that that's the other side of the coin.
Wow. Yeah, that's a good point. Yeah, very interesting.
Cool.
I did want to ask, yeah, one more question before we wrap up. So, what's next for your company? What are you trying to achieve?
Yeah. So we're trying to build really good systems. We're trying to build systems and software that kind of supports our underlying products. Like, so we're a product company. And I think that that's an important distinction. Lots of defense and government contracts just end up being um, services. And pretty much all companies kind of in that way are services to some degree in government contracting. But we're trying to make good products. And I think that, by having the team that we do and taking our products and our ideas and then our technical execution of those things to the level that we're trying to play at, I think that we're going to grow. I think that, eventually, whether we raise VC or not, we're going to start making a little bit of a splash in this kind of small sensor AI enabled market. Um, and who knows? Like, there's all kinds of like end games, but I do think that right now I'm doing this thing, and I feel like I'm learning how to do it well, and I think that it would be awesome to take this into a fully fledged like company, like not like one that we came from before, but one that has the like the actual engineering like impact on the world that it could, as engineers who are in trying to do things that I think are kept in mind as good for the world, right? We're trying to take people out of bad situations. We're trying to secure places from drone incursions. Like, I think that those are all good efforts. And if we can do that at scale, like that would be a dream come true. That would be awesome. So I hope that that's where we'll end up, but we'll see. I mean, there's no way to chart a straight line through the next couple of years, I think, in any respect. So we'll see how things go.
Awesome. Great. Thank you so much for coming on the podcast.
Yeah, thank you so much for having me. This was a pleasure, Luke. I appreciate it.